All right, folks, welcome back. This is lesson 7.3.2. We're talking about coordinate geometry and midpoints. Coordinate geometry and midpoints. A couple warm-up questions here just to get us thinking with some skills we'll need in this lesson. Question number one, how do you find the middle of two numbers? Well, we call that an average, also known as mean. And the simple way of finding the two numbers is you add them. After you're done with that, you divide by 2. It's just that simple. So if we want to find the middle of two numbers, like let's say 6 and let's go with 14, we do 6 plus 14, divide by 2. 6 plus 14 is 20. Cut that in half. We get 10. It's that simple, folks. This next question is a little bit trickier. Let's say we have three numbers, 5, 12, and a. If 12 is halfway between 5 and a, what is the value of a? Well, really that means 12 is the average of 5 and a. So we could set up this equation that kind of looked like this: 12 equals 5 plus a over 2. And we could then multiply both sides by 2. That gives us 24 equals 5 plus a. And then we could subtract 5 from both sides, and we get the result here that says 19 is a. That's one way to do it. There's a little bit easier way to do it, to think about it, rather than using all of this algebra. Let's say we've got the number 5 right here, and then we've got the number 12 right here. It's in the middle of 5 and a, so I'm going to kind of draw it like this. How far is it from 5 to 12? Oh, that's plus 7. So to get from 12 to a, we do another plus 7, and that gives us a equals 12 plus 7, or 19. So two different ways to kind of skin that cat there, folks. Now let's jump into the notes page. You are going to need two things. You're going to need to print out a copy of the notes page, and you want to reference your quadrilateral org chart. All right, folks, here we go. We got the notes page here. Lesson 7.3.2, coordinate geometry and midpoints. First thing here says to look at the quadrilateral org chart and find a theorem on mid segments. I want you to do that right now. So I'm going to pause and wait. No, seriously, get out the quadrilateral org chart and look for the theorem on mid segments in the bottom right hand corner. Okay, we're going to prove this theorem with a simple little example for triangle ABC, where A is at the origin 0, 0, B is at 2, 6, and C is at 7, 0. First thing we're going to do is graph triangle ABC, and I want you to do me a favor. Students have a tendency to do this. Do not do what I'm about to do. You're given a sheet of graph paper and you're asked to plot some points, so you just say, yep, I'm putting the origin right in the middle because that's the way I was taught to do a long time ago. Don't do that, folks. What I really want you to do is think about where the origin should be. Okay, we've got 0, 0, 2, 6, and 7, 0. So all of those points are in quadrant 1. So why not put our origin somewhere over here? Okay, so now I got my y-axis drawn in, got my x-axis drawn in. Let's go ahead and plot this bad boy. A is right there at the origin. B is at 2, 6. And C is at 7, 0. Okay, let's go ahead and draw in the triangle. There you have it, folks. There's triangle ABC. Now let's, so we've done part A here. Check. Let's do part B. Find the midpoint of segment AB. Well, the midpoint of a segment is just the average of the x and y coordinates. That's it. That's what we were just doing on that warm-up problem, is finding the average of two numbers. So for point P is the going to be the midpoint of segment AB. It's just going to be the average of 2 and 0, the average of 6 and 0. That's pretty straightforward one. Hope you don't need a calculator there. Point P will be at 1, 3. Let's go ahead and add that to our picture. Point P is at 1, 3. That's the average of the coordinates for A and B. Next, let's go ahead and find the midpoint of BC. We're going to call that Q. Again, it's the average of the x and the y, so my x coordinates are 2 and 7. My y coordinates are 6 and 0. Uh-oh, this one's a problem. 2 plus 7 is 9. 9 is not evenly divisible by 2. 6 plus, oh boy, look folks, do you see that mistake? That should be 6 plus 0 divided by 2. That's 3. And I know some of you are panicked right now because you're like, OMG, I got 9 over 2. I can't think in fractions. So just go ahead and write that as a decimal if you choose. So there you have it. We got point P, the midpoint of AB, and point Q, the midpoint of BC. Let's go ahead and plot Q here. Let's just go ahead and graph in that mid-segment. Remember, the mid-segment of a triangle connects the midpoints of adjacent sides. Now, because I constructed point P as a midpoint, it might be nice to add these congruent marks here. And since Q is the midpoint of BC, I can add these congruent marks here. That's a nice little add just to make our picture more complete. All right, we are done with part B. Let's now go into part C. So part C asked us to show that the length PQ is half the length of AC and verify that PQ is parallel to AC. That's a symbol. I want to make sure you remember what that symbol represents. So let's start here and use the distance formula to calculate the length of segment PQ. Now really, we're calculating the length of a horizontal segment. A horizontal or vertical segment, it's easy enough to count squares on graph paper to figure out how long they are. I'm just showing you the formula here so you have some more experience with it. So let's take a look. Our delta x from P to Q is going to be 4.5 minus 1. And then our delta y, that's because we're a horizontal segment, 3 minus 3 is 0. And that's why this formula ends up being kind of easy and ridiculous to use if we're just literally counting a horizontal distance. But that ends up being 3.5 units. So that's PQ. Now let's find out AC. That one we can easily count squares on the graph paper because we go from 0, 0 to 7, 0. So that's 7 units long. 7 units long. We're asked now to show or verify that half of the length AC, which is half of 7, is equal to length PQ, and that's easy to see right there. The second thing we're asked to do is show that PQ is parallel to AC. Let me finish that over here. Well, let's see. PQ, segment PQ, is parallel to segment AC. Folks, both segments are horizontal. We know for segments to be parallel, they have to have the same slope. Because both segments are horizontal, they both have a slope of m equals 0. Horizontal segments have a slope of 0. Okay, that's it for problem 7-126. Let's now look at 7-127. All right, folks, let's jump down here to question 7-127. What if I already know the midpoint? I think in a few minutes you'll see this is very similar to the second warm-up problem we did. The textbook problem actually has 3 parts, A, B, and C. I'm only going to do part A here. If you're interested in parts B and C, go ahead and look at the version of the notes I posted online that's labeled as old. This one I kind of abbreviated just to do what I think is the most critical part of the problem. Okay, so we're going to draw segment AM with the coordinates 3, 4 and M with the coordinates 8, 11. Then we're going to extend that line segment to find a point B so that M is the midpoint of segment AB. Now this one, don't draw anything just yet. I just kind of want to sketch what's going on here. So we have point A here, and then we have point M, and they've given us the coordinates of that, and we know we can draw a segment there. And then the problem says we're going to take that segment and we're going to extend it so that we put a point B on there, that ends up being the midpoint of segment, so that M is the midpoint of AB. So that means we're going to be able to move this point. This point B, we're going to find out where it's located exactly so that this segment equals this segment. AM and MB are the same. All right, now I'm going to go ahead and plot some of this stuff. Let's erase this stuff. We don't need that anymore. So let's go ahead and plot this problem. You'll notice that I gave you a bigger set of bigger graph here to work with, and that's because some of these coordinates are larger. Remember what I said previously, though. Don't automatically put your origin in the middle of the graph paper. That would not help you here. You'll run out of space. In fact, this is a well-designed graph so that you have exactly the amount of space you need. So I'm going to go ahead and add my y-axis all the way over here on the left-hand side. That's going to be my y-axis. And I'm going to put my x-axis on the bottom, about right there. So let's go ahead and plot these points. A is at 3, 4. And B is at 8, 11. I think I called that B. I'm sorry, I meant that's M. Okay, and we know that there is a segment here that continues beyond this, and we have to find out where point B is on that segment. So I'm going to kind of show you 2 different ways to do that. I'll call method 1, I'll call it a numerical approach. And let's first start by looking at x values. So we know that the x value for point A is 3. And we know that the x value for point M is 8. Now, how far is it from 3 to 8? It's plus 5. So that means point B has to be 5 more units to the right of 8. Let's see, 8 plus 5, that's 13. And again, these are points A, M, and then B. And we're talking about the x coordinate. Now let's do the same thing for y coordinates. For point A, the y coordinate is 4. For point M, the y coordinate is 11. To get from 4 to 11, you have to add 7. That means we have to add 7 more to get from M to B. And when you add 7 to 11, you get 18. So there's the y coordinate of point B. So point B ends up being 13, 18. All right, now I want to show you method 2. And method number 2 is graphical. This is a bit harder, I think, than the numerical approach, because if all of a sudden I changed points A and M and I made them in the hundreds or in the thousands in terms of the x and y coordinates, it's tough to graph things that large. So let's just take a look graphically at what we can do here. Well, I know that I can sketch in a triangle right here, and I'm going to do it in 2 different colors for a reason. And I know that this triangle has, let's see, to go from this vertical leg here goes from 4 to 11, so that's a vertical change of 7. And then that horizontal leg goes from 3 to 8, and that's a change of 5. If I do that same thing again, I go up 1, 2, 3, 4, 5, 6, 7. And then I have that horizontal change of 5. 1, 2, 3, 4, 5. I end up where I think point B is. And again, I have that vertical change of 7, that horizontal change of 5, and let's see if it worked. Sure enough, when I sketch segment AB again, it goes right through point M. So 2 different approaches there to find the coordinates of point B. Again, that ended up being 13, 18. All right, folks, we're going to shut it down and pick up page 2 in another video.